Hi guys, so now I'm going to teach y'all trigonometry substitution method. Okay, so basically trigonometric substitution method, we have three things, okay? So we have three things over here. So the first thing is when your constant square minus s square. Okay? Second thing is, I'm just going to write close a bit. Okay? Second thing is your s square minus constant square. Okay? Your third thing is your constant square plus with s square, or maybe vice versa. Okay, s square plus a square. Okay, it's just the same thing. So what you're going to do is you're going to start one by one. Okay, when your constant minus s square, you're going to let your s become a constant sine theta. Our first question, which is integrate set 4 minus s square ds over here 0 2. Okay, so what you're going to do is, you see over here your constant square, your 4 actually your 2 square. Okay, your 4 is actually 2 square. So here you're going to have constant square minus s square, which is your constant square minus your s square. So you're going to let your s become a, which is your 2 sine theta. Okay, you just differentiate it. Okay, so I'm going to write the step over here. The first going to substitute. The second one going to differentiate. Okay, so here when you differentiate sign, going to be cos theta d theta. Okay, so now you just substitute your s over here, and your dx right now going to be this one. Okay, so just substitute it. Okay, your this one going to be 2 square minus here going to be bracket 2 sine theta square. Your dx right now going to be 2 cos theta d theta. Okay, so now your bound you need to change also. Okay, because this one is actually your s. Okay, we want in the form of theta right now. So when your s equals to 2, your theta going to be, so 2 over 2, wait okay, 2 over 2 going to be 1 sine arc sine going to have here pi over 2. Okay, when your s equals to 0, so 0 over 2 going to be 0, arc sine going to have 0 as well. So here is 0, you're going to be pi over 2. After that, we're going to do it, just solve it. Okay, so you have your 2 sine theta square. So what you're going to do is just expand your square. So here you're going to have 2 and also sine square theta. Okay, sine square theta. As you can see over here, we have 2 square, also 2 square over here. So we just factorize it out. So we have pi over 2 0. So we have 2 square. Here going to have sine, or here going to have 1 minus sine square theta. Okay, and here also you're going to have cos theta d theta. Okay, so now what you're going to do is just split the set. Okay, so you're just going to split the set. You're going to have set over here as well. Okay, so now your 2 square set. Okay, so you're going to have here 2, okay, 0. You're going to have here 2, so you're going to have here 2. Here you're going to have, okay, your 1 minus sine square theta is actually cos square theta. Okay, so you just substitute in, so square theta. Okay, so you're going to be 2 cos theta d theta. So now your cos square theta set, so the square going to disappear as well with the set. So now 2 times 2 is 4. You just bring a 4 to the front here. Okay, so cos with the cos square theta d theta. So when you want to integrate cos square theta d theta, so what you're going to do is just change this cos. You're going to be 4. Okay, here going to be 1 plus cos 2 theta over 2. Okay, by using this property. So now these two I can just bring out. Okay, I can just bring out. So I can cut here. Here the outside going to be 2 as well. So now, okay, I just going to erase this part. Okay, just going to erase this part. Okay, we're done with this part. Okay. Okay. So now, you just have to pi over 2 0. Okay, so you're going to have 1 cos 2 theta d theta, and now you just integrate it. Okay, when you integrate 1, you're going to have theta. When you integrate cos 2 theta, you're going to have sine 2 theta over 2. Okay, so here going to be 0, it's going to be pi over 2. Okay, so you just substitute in pi over 2 over here. Here going to be pi over 2 over here. So sine pi over 2 times with 2 over here divided by 2. Okay, that's the first column, the first bracket. The second bracket, 0 over here plus with 0. So sine 0 going to be 0 as well. Okay, so now 2 over here, and then we're going to have pi over 2 plus with. So now sine pi going to be 0. So your last answer going to be pi. Next, our second question, which is integrate 1 over s squared plus 1, and then power 3 over 2 over here dx. So the first thing, your 1 power 2. Okay, your 1 square. So now your s square plus with the constant square, which is this one. Okay, so what you're going to do is just substitute your s equals to your a is 1 times with the tangent. Okay, tangent theta. Okay, so you don't write your 1 over here, so just tangent theta, then you differentiate it. Okay, tangent theta secant square theta d theta. So after that, you're just going to substitute in. So 1 over your s going to be tangent square theta plus 1. 3 over 2. Your ds right now going to be secant square theta. Okay, so here going to be secant square theta d theta. Okay, so after that you're going to do your tangent square theta plus 1, actually your secant theta. Okay, so what you're going to do is just substitute in. So here going to be secant square theta over secant square theta power 3 over 2 d theta. Okay, so now your square times with your 3 over 2. So you're going to have over here is secant cube. Okay, you're going to have here secant cube. So you just need to cut over here. So you're going to have secant only. Okay, so you're going to have here only 1 over secant theta d theta. So you just bring your secant. Bring out your secant, going to be cos over here, cos theta d theta. So you just going to differentiate it, going to be sine theta plus c. So now you want to integrate in the form of ds. Okay, for the previous question I forgot to change to ds. Okay, so now for the second question I'm going to change to ds. Okay, but actually for the first question also I need to change to ds as well. Okay, I need to change to s. Okay, so now your tangent equals to your s. Okay, your tangent equals to your s. Your tangent equals to your s over here, and you know your tangent is opposite over adjacent. Okay, so now your s actually s over 1. S over 1. So if you see the triangle, okay, your opposite is 1, as your adjacent is 1. So now your hypotenuse is going to be s square plus 1. Okay, going to be s square plus 1. So now your sign over here, your sign is actually opposite over adjacent. So you're just going to change over here, opposite over, okay, your sign over here going to be opposite, which is your s over adjacent, which is your s square plus 1. Okay, so you're going to have here s square plus 1 plus c. Okay, and now our third question, which is you need to integrate s cubed, here going to be s square minus 4 3 over 2 dx. Okay, so now you have your s square, your 4 actually 2 square. Okay, so now you have s square minus constant square, which is this one, s square minus constant square. So what you're going to do is just let your s equals to your a now 2, then secant theta. Okay, so you're just going to differentiate it to secant, going to be secant theta tangent theta d theta. Okay, so you just substitute in, okay, your s cube right now going to be this whole thing's cube. Okay, so s cube going to be 2 secant theta cube. Your this one going to be 2 secant theta square minus 2 square power 3 over 2 ds. Okay, then what you're going to do is just going to expand it. You're going to expand it. So 2 cube going to be 8 secant theta, and then 2 square going to be okay, here I just going to do like this. 2 square going to be 2 square secant square over here minus 2 square power 3 over 2 ds. Okay, so now you have 2 square over here. You can just factorize it. Okay, factorize it, going to be 2 square over here. So here going to be secant square minus 1. Okay, so now your 2 square, you're going to expand it. Okay, you're going to expand it. Your 2 square power 3 over 2. Okay, so what you're going to get is 2, okay, 2 cube. Okay, so now here going to be cube also, here going to be 3 over 2 also as well. Okay, so before I expand it, you know that secant square theta minus 1 is actually your tangent square theta. So I just going to substitute in. Okay, just going to substitute it back. So you're going to be tangent square theta power 3 over 2. Okay, now here going to be square, here going to be 3 over 2. So I just going to have over here tangent cube. Okay, so now my ds, okay, my ds is 2 secant tangent theta. So I just going to solve it over here. I can solve it at the beginning, but there is no space over there, so I just started it over here. So now your ds actually 2 secant theta tangent theta d theta. Okay, then here 8 times 8 going to be 64. 64 times 2 going to be 128. So just bring the constant out here. Okay, so here you're going to have secant with secant, so secant square. Okay, and then tangent with tangent power 4 d theta. So after that, what I'm going to do is, okay, I'm just going to erase this part. Okay. Okay, so I'm just going to erase this part. So what you're going to get is, you're just going to let your u equals to tangent theta. Okay, so now you're going to differentiate it, which you're going to get du equals to secant square theta d theta, which you're going to eliminate over this one, secant and also d theta. So now I just going to substitute over here 128. Okay, secant theta secant square d theta going to be your du. Okay, now your tangent going to be your u power 4. Okay, so now you just integrate it, which you're going to get u power 5. You're going to get 5 as well, and then plus with c. So your last answer going to be 128 over 5 u power 5. Okay, so now your u actually your tangent theta 128. So I just going to substitute it back. So tangent theta power 5, okay, plus c. Now I don't want in the form of tangent, I want in the form of x. Okay, so because I want to integrate x over here, so like just now I let my x equals to tangent. Okay, just now I let my x equal to 2 secant theta. Okay, so now as you can see over here, secant actually 1 over cos theta. Okay, 2 over here, s over here. So I just going to bring this 2 down here, going to be 2. Okay, so now I want cos on the top, so cos theta. So here I'm going to make it upside down, 2 over s. Okay, so now I don't want cos, I want tangent. So I'm going to do triangle. Okay, now cos actually adjacent over hypotenuse, which my adjacent going to be at 2, my hypotenuse going to be s, so my opposite going to be s square minus 2 square, okay, which is 4. Okay, so now my tangent is actually opposite over adjacent, so here going to be opposite, okay, over adjacent, which is my 2, okay, and power 5 plus c. So yeah, that's the last answer. Okay, you can just cut here. Okay, it's going to cut here 1 to 8. You're just going to cut over here. It's going to get 64. Okay, so you're going to here no longer have 2 power 5 over here. Okay, that's all. Next, our fourth question, which is integrate 1 over s squared minus 8 dx. Okay, so now we have s squared minus constant, okay, which our constant actually is set 8 square. Okay, set 8 square. Oh, okay, you can have here square. Okay, so we just let our x, okay, when x square minus the constant going to be secant. So here going to be set 8 secant theta, and then we differentiate it ds 8 secant theta tangent theta d theta. So now I just substitute it. Okay, my x actually 8 secant theta, here going to be square minus 8 square over here, and then my dx going to be set 8 secant theta tangent theta d theta. Okay, so after that what we're going to do, okay, we don't need this one, so what you're going to do is just expand it. Okay, when we expand it, what we're going to get is, okay, here I'm going to copy it back, tangent theta over, okay, so now 8 square, okay, set 8 square with secant square, okay, secant square theta minus set 8 square. Okay, as you can see over here, we have the same set 8 square, so we just factorize it, and then here going to be 1. Okay, like I said just now in the previous question, which your secant squared theta minus 1 actually your tangent squared theta. Okay, so we just substitute over here. Okay, so now what we can do is we substitute this whole thing become tangent squared theta. So we just write here tangent squared theta. Okay, then what we can do after that, we can simplify this set 8. So set 8 divided with set 8 square. So here going to be disappear, here going to have set 8 only. So now we have tangent and also tangent squared, so we can just cancel this tangent and we only have tangent power 1. So now we have secant, which is our okay, it's okay. I just bring out the 1 over set 8 over here. So I have tangent over here, tangent theta d theta. Okay, so now we know that our secant is 1 over cos and our tangent is sine over cos. So we change it. Okay, we change it in the form of cos and also sine, which is your secant is 1 over cos theta, your tangent is sine over cos. Okay, why inverted? Because your tangent right now is at your denominator, so it's going to be inverted. Okay, so now what you're going to have here, you're going to cut over here. Okay, you're going to cut it, the cos, so you're going to have sine 1 over sine, actually your cosecant. Okay, so you're going to have here cosecant theta d theta. So what you're going to do after that, okay, I'm just going to erase this part because I don't need it. Okay, I'm just going to erase this part, and okay, I just need this as, okay, as equals to set 8 secant theta. Okay, I'm just going to erase this part. So what I'm going to do is, I need to, when I have cosecant, okay, when I have cosecant, where I'm going to write, okay, when I have cosecant, okay, I need to times with cosecant plus cotangent over cosecant plus cotangent. Okay, if I have cosecant only, if I have secant only, okay, if I have secant only, what I'm going to times with secant plus tangent over secant plus tangent. You need to divide with the same thing, only can cancel to each other. Okay, you need to remember these two. Okay, so when we have cosecant, you need to plus this one. Okay, you need to time with that one. Okay, so we're going to get over here 1 over set 8. Okay, your cosecant right now, you need to times with cosecant cotangent, okay, theta plus cotangent. Okay, cotangent theta over the same thing, d theta. Okay, so this is what we're going to have. So after that, what we're going to do is you're going to expand it. You're going to expand it. Okay, so you're going to have cosecant square theta plus cosecant theta cotangent theta over cosecant theta plus cotangent theta d theta. So after that, what you're going to do, you're going to sub, which you're going to let your u be equals to your denominator. Okay, denominator always, okay, always equal to your denominator, which is cosecant theta plus cotangent theta. So what you're going to do after that, you're going to differentiate it. Okay, du equals to, here cosecant theta, differentiate going to be cosecant square, cosecant cotangent, okay, cosecant plus cotangent, oh my god, cosecant cotangent theta. Okay, you're going to have minus over here, you're going to have minus, and another one you're going to differentiate cotangent, going to have minus cosecant square theta d theta. So I just going to shift this minus to another side, which is minus du equals to cosecant theta cotangent theta plus cosecant square theta d theta. So as you can see over here, this one actually your numerator. So the whole numerator going to be your du over here, going to be your du. So now here I'm just going to get 1 over 8. Here the top one going to have du only. Your denominator going to have u only. Okay, until here you can be happy ever after. Okay, so you're just going to bring this minus outside. Okay, so differentiate 1 over u going to be ln. Okay, integrate 1 over u going to be ln. Okay, you're going to be ln u plus c. So now I don't want in the form of u, I don't want in the form of cotangent secant, I don't want in the form of x. Okay, so now I'm going to sub my u back. My u is actually cosecant plus cotangent. Okay, so I'm just going to erase this part. Okay, my u is cosecant cotangent. Okay, set 8 ln u is actually cosecant cotangent, cosecant theta plus cotangent theta plus c. Then what I'm going to have, I don't want in the form of theta, I'm just going to have in the form of x. So now just I let my x equals to set 8 secant theta. Okay, so now my secant theta actually 1 over cos theta. So I just bring this 8 to another side, going to be 1 over set 8, and then I need to make it inverted. So cos theta equals to set 8 over x. So now here is your cosecant, actually your sine theta. Here going to be your 1 over tangent theta. Okay, plus c. Okay, so you're going to substitute it back later. So now your cos actually equal to this one, so you need a triangle. You always need a triangle. Okay, you need a right angle triangle. So now cos adjacent over hypotenuse, adjacent over hypotenuse. So your last one here going to be x squared plus 8. Oh, minus 8. Okay, so now you want your sine, which is your sine Okay, I just going to copy it back. Set 8 ln, which is your sine is actually this one, your opposite over hypotenuse. Okay, so but this one is 1 over, so your hypotenuse over opposite. Okay, plus your tangent is opposite over adjacent, but 1 over tangent, so adjacent over opposite. So adjacent over opposite minus 8. So that's what you're going to get. Or maybe you can just combine it together. Okay, just your last answer is going to be set 8 ln s plus set 8 over s square minus 8 plus c. Okay, so yeah, that's for the fourth question. So we're moving on to the fifth question. So now fifth question, which is integrate 1 over set s square plus 9 ds. So now your 9 actually 3 square. Okay, so now you have here. Okay, so you need to let your s equals to, so I'm just going to write my s over here. I let my s equals to 3 tangent theta. So I differentiate the as 3 secant squared theta d theta. So what I'm going to do later, I'm going to substitute. Okay, I'm going to substitute it. So I'm going to have here s squared. So s squared 3. Okay, 3 square. So I'm going to have here tangent square plus 3 square. Okay. My ds right now going to be 3 secant square theta d theta. Okay. So from here I can just factorize it. I can factorize the 3 square. So you're going to be 1. So you know that your tangent square theta plus 1 actually your secant square theta. So you just substitute over here. Okay, you just substitute over here. Going to be secant square theta. And then your 3 square set. So what are you going to have over here? Okay, like this. So you're going to split the set first. Okay, you're going to split into 2. So you're going to have over here and over here as well. So now 3 square set, you're going to have 3 only. Okay, so now your secant square set, you're going to have secant only. You don't have the square and also the set. So now you can just cut over here. You can just cut the 3 and also you can just cut the secant. So what you're going to have over here, you're going to have secant theta d theta. Okay, like I said just now in the previous question, when you have only secant, so you need to times with secant theta plus with tangent theta over secant theta plus with the tangent theta. Okay, so here going to be d theta. So you're just going to expand it. So secant theta, secant square theta, tangent square theta, tangent secant theta tangent theta over secant theta plus tangent theta d theta. So after that, what you're going to do, you're going to let u equals to your denominator, always your denominator, and then your du right now going to be secant theta tangent theta plus with the secant square theta d theta, which is your numerator. So you just change it. Okay, you just change it. Your upper part going to be du, your denominator going to be u. So you just integrate u, which is we're just going to integrate 1 over u, which is going to get ln u. Okay, so now I don't want in the form of u, I want in the form of s. Okay, I want in the form of s over here. So you're going to sub your u back, which is your u equals to secant square secant theta plus tangent theta plus c. Okay, so I want to sub back. Okay, to sub back. Okay, just going to erase this one. Okay, as you can see over here, we have s equals to 3 tangent theta. Okay, so I just shift that 3 to another side, so we have tangent equals to s over 3. Okay, so we make a triangle. Okay, now we have tangent already, but now we want only secant. So now our tangent is opposite over adjacent. So now our hypotenuse is going to be s square plus with the 3 square, which is 9. Okay, so we just substitute it back. Okay, we need to find our secant. Secant actually 1 over cos theta. Okay, so we need to find our cos. Our cos theta is equals to adjacent over hypotenuse. Okay, plus 9. So now we want 1 over cos, so we need to make it upside down. So our last answer is going to be ln. So s square plus 9 over 3 plus with your tangent is s over 3. So make it together over here. You can make it together. Combine it together. Plus over 3 plus c. Okay. That's all for the 5th question. So we're moving on to the last question. So our last question, which is integrate 1 over s square plus 16 dx. Okay, so what you're going to do, you know your 16 is actually your 4 square. Okay, now your s square plus with the constant square, which is your tangent. So you need to let your s. I'm just going to write here, let your s equals to your a going to be 4, then tangent theta over here. So just going to integrate it, going to differentiate it, going to be here secant square theta d theta. So what I'm going to do over here, going to sub it. Okay, going to sub it. So your s is going to be 4 square tangent square theta plus with the 4 square. Okay, and then your ds right now going to be 4 secant square theta d theta. Okay, so now you have 4 square over here, 4 square over there also. So you just factorize it. You have 4 square over here, then you have tangent square theta plus 1. Okay, you have secant theta. Okay, so now you know that your tangent square theta plus 1 is your secant. So you just substitute it back. Okay, just substitute it over here. Your secant square theta. Okay, so what you're going to do after that, you're going to simplify it. So you have 4 here, you have 4 here, so you can cut over here. So you only have 1 over 4. Okay, so here you have secant square, you have secant square over here. So you cut over here, you're going to have 1 d theta. So the last answer is going to be 1 over 4 theta plus c. But now we don't want in the form of theta, we want in the form of s. So what we're going to do by using this one, for tangent theta, you just find your tangent, you just find your theta, which is your arctangent, okay, s over 4. So you just substitute back over here, 1 over 4 arctangent s over 4 plus c. Okay, so yeah, that's all for the trigonometry substitution method. It's quite complicated, but you just follow my step, just take a note for my step, and yeah, it's going to be easy for y'all. So yeah, see you guys in the next video, and bye bye.